Hello, everyone. Welcome back to Service Mesh Academy. I'm Flynn. With me is Russ Palmer from Weaveworks, and we are going to be talking today about GitOps with Weaveworks GitOps and Flagger and Linkerd. I'm a technical evangelist for Buoyant, spreading the good word about Linkerd. Russ, you want to say a couple words about who you are and what you do?
Sure. My name is Russ Palmer. I am a senior engineer at Weaveworks. Do a lot of the enterprise enablement and did some of the Flagger work for our UI as well.
Cool. And to remind everybody, we are going to be mostly doing chat via Slack today. That's the workshops channel on the Linkerd Slack at slack.linkerd.io. That is a great place to go if you have questions about the workshop or if you want to follow along and heckle us or something. You can also go into the Linkerd 2 channel on the Linkerd Slack if you have more general Linkerd sorts of questions. I see people waving from Slack, which is wonderful. I see people in the chat here, which is also wonderful and lets us know that some things are probably even working. It's always nice when that happens. So let's go ahead and get this show on the road. Yes, this is us. This is how you reach us. You can email me at flynn@buoyant.io or Russ at russell.palmer@weave.works. It's easy to find both of us actually on the CNCF Slack. I'm at Flynn on the CNCF Slack there as well. You can find me at the Linkerd Slack also. Today, we're deliberately trying to do this light on the slides and then have some more time to go in for the demo. So we're going to do a very quick introduction of GitOps and service meshes. We're going to do a quick introduction to Linkerd, Flux, Flagger, and we have GitOps, and then we're going to go dive into the workshop. To follow along with the workshop, which we hope you do, I mean, you don't need to, but it's usually more fun to follow along, we think. You will need a Kubernetes cluster, an empty Kubernetes cluster. Let's be specific about that. I'm going to be doing this with a K3D cluster, but it should work with pretty much anything. It's currently set up to assume that you can use services of type load balancer. So if you have a cluster where you cannot use a load balancer service, you're going to need to edit a couple of things. You will need the kubectl CLI. There's stuff in the demo that's set up to use YQ and BAT. You could probably get away without that if you really want to. You'll need the Flux CLI for certain, and the Linkerd CLI is always nice to have. The workshop source is on GitHub. If you've been following earlier Service Mesh Academies, please note that is a different repo. This is not a directory within the main Service Mesh Academy repo. It's a separate repo just for this workshop because part of the workshop requires that you clone that repo and commit to it and do things like that, or commit to your fork. Sorry, let me back that up. The workshop requires that you fork that repo and be able to commit to your fork. So there's some setup you need to do that just felt like it would be unnecessarily awkward to leave in the big Service Mesh Academy repo. All right, let's get into a very quick intro to GitOps. Fundamentally, GitOps is this idea that instead of modifying the cluster directly, you will keep all of your cluster's configuration in Git or some equivalent source of truth where you have version control and you have transactional commits and things like that. Then instead of just doing things like kubectl apply or helm install, you will instead change the things stored in Git, push those changes to your Git repo, and then have a tool running in your cluster which will notice the changes, pull them out of Git, and apply them to the cluster for you. The important thing here is that the GitOps tooling will keep your cluster in sync with what is in Git, which means that if you make a change to Git, it will change the cluster. But it also means that if you change the cluster directly, the tools will undo your change to make the cluster look like what's in Git. So if you're going to do GitOps, do all GitOps. Don't try to mix and match because that will cause you a lot of trouble and it might be very confusing. If you go to opengitops.dev, you will find the CNCF definitions of the GitOps principles. This is a more formal way of saying what we just covered. You've got a bunch of YAML that expresses the state of your system declaratively. You're going to store that state in a way that enforces immutability without particular change processes. It has versioning. You've got a complete version history, so you can roll backwards if you need to. You have agents running in the cluster that are pulling from your immutable store and making the cluster look like the stuff that you've expressed declaratively. And they're going to do that continuously and make sure that if there are places where they diverge, it's going to try to make the cluster look like the Git repo. This is kind of the core idea behind this concept of me hitting the wrong slide thing too quickly. Let's go back to that slide. Excellent. This is how you know we're doing this live. So this is the core idea behind GitOps and Cloud Native, where everything you do, you're going to make a Git commit, usually with a pull request so it can be reviewed. And then this is going to constantly be running through this cycle where you can go through and make changes locally, run them through testing, eventually get happy with it, commit it to Git, and then the kube GitOps stuff will go through and cycle that through to make the cluster look like what you've just committed. Russ, is there anything you wanted to add to this before we get into some of the other concepts?
No, that was a really good explanation.
Oh, good. I should, behind the scenes, a lot of this explanation I got by talking to Russ earlier. So let's talk a little bit about service meshes. This is the really quick intro. There are a lot of other service mesh academies where you can go through and get a lot more detail about what the service mesh is. It's basically an infrastructure layer that provides security, reliability, and observability all across your application in a uniform way down at the platform level, usually without requiring any changes at all to the application code. This permits you to separate the concerns of working on the application from the concern of the care and feeding of your cluster and your infrastructure. And it typically lets you let your application dev team focus on your application and have a platform team that's focusing on the care and feeding of the platform. Those roles could be filled by the same person, obviously, especially in a smaller organization. But one of the nice things here is that they don't have to be the same person all the time. Under the hood, most meshes out there, certainly including Linkerd, work by putting proxies, hopefully really small, fast, lightweight proxies, next to each of your application workload pods. Then the proxies end up mediating all of the traffic in between the pods. There are a couple of clusters out there that don't do it this way, but this is the most common way for this to do. And we can talk at great length about why we think this is the right answer. But for right now, let's just leave it at this. There's also, in the interest of completeness, there's a control plane, which is a set of other pods that are managing all of these proxies for you. Very, very quick intro then into the products that we're going to be looking at today. On the GitOps side of the world, you've got a Git repo. Flux is the tool, Flux from Weaveworks, is the tool that we're going to be using to actually keep the cluster in sync with what's in the Git repo. So Flux constantly notices things going on in the Git repo. It constantly notices things in the cluster. It tries to keep them the same. Other relevant bits here are that we've got an Ingress controller. We're using Nginx for that today. We've got Prometheus that is handling metrics for us. Flux kind of interacts with that stuff, but where those really come into their own is when we start talking about progressive delivery and bringing Flagger into the mix. Flagger is the piece of the world that notices when you've made a new change to a deployment and then actually rolls that out as a canary or an AB or something like that, so that you can find out if your new deployment worked rather than just slamming it into production and hoping for the best. Flagger does this by first interacting with Flux, but also Flagger will then interact with Linkerd and Nginx, really, although that arrow isn't on this diagram. And the other important thing here is that Flagger will be always watching the metrics in Prometheus to determine whether or not the new deployment is working. When Flagger is working with Linkerd, those metrics are usually being populated by Linkerd. This does imply that Flagger and Linkerd need to be using the same Prometheus instance, or all sorts of things get very confused. And again, anything you wanted to add to that, Russ? I feel like I'm
No, I just
missing
wanted
something.
just the one thing to kind of point out is that Flux is your reconciler. It's going to be the one talking to the app repos. It's going to be one looking for the changes. It's going to be the ones looking for version changes and things like that. And it's actually going to pull those changes into the cluster to update your deployments, services, anything that goes along like that. And then what we've got here with Flagger works on that another layer on top of that. And once those changes have been detected, Flux has pulled them in and deployed them. Flagger is going to be the one to kind of do that rollout and to verify that the change you made works, and if that should actually go be the live deployment or if it should not.
Yeah, that's an excellent point, that Flagger is relying on Flux to do all of the underlying Git stuff. There was also a question that I just noticed in chat about the versions of tools we'll be using. Yeah, pretty much the latest and greatest. In particular, we're using Linkerd 2.12, and I think we're actually using 2.12.4. And I don't remember the version number for Flux and Flagger, but they're the latest versions of Flux and Flagger.
They're set the latest, so yeah. The latest versions are good.
All right, so there we go. We've talked a little bit about service meshes. We talked a little about GitOps. We've talked a little bit about the products we're going to use. Let's talk a little bit about the application that we're going to use during this demo. This is a simple thing called the Faces demo. It was deliberately designed to demo something easy to understand that still has a call graph that's more than one layer deep. So we've got a GUI, it's a single page web app that is talking to a face service. The face service in turn talks to the smiley service and the color service. The smiley service should always return a smiley face. The color service should always return the color green. The face service is going to put those together. And so what we should be seeing is a grid of smiley faces on green backgrounds. I'll go ahead and tell you up front, there will be points in this demo that is not what we see, but that's what we're supposed to see when everything is working right. In this particular application, we have Nginx mediating access from the GUI into the face service, and then we have Linkerd mediating all the communications within the cluster. So that's the app we're using. There's really nothing too dramatic about it. And with that, it is time to see if the demo gods are going to smile upon us. I've already set up my cluster. It's empty. There's nothing in it. So the first step here is to use Flux to bootstrap the world. When we do this, what's happening here is I've got the Flux CLI installed on my laptop. The Flux CLI is going to go and inject a bunch of stuff into the cluster and set things up correctly to talk to my Git repo. And then it is going to sort of do this bootstrapping thing where it waits for itself to become ready, the core Flux components that are now living on the cluster. After it does that, and it's got the core Flux components working, then it will start watching the other things that we've told it to pull in and see if wait for them to be ready. In this one, when we look at these particular reconciliations, we can see that the Flux core is good. We can see that Cert Manager and Weave GitOps are both being reconciled, although they haven't finished yet. All this reconciliation and bootstrapping stuff can take a little bit of time, so we're just going to sit there and watch it happen. So what we've gotten here is we can see that Cert Manager became ready, Weave GitOps became ready, and so now we're working on reconciling Linkerd itself. This is the part that honestly takes a little bit longer than I would like for a demo. So I don't know, Russ, anything you want to point out here? Got any good jokes?
No jokes, but I just kind of wanted to point out why this is not all kind of reconciling all at the exact same time.
Because that would be a horrible idea.
Because that would be a terrible idea, and then who knows what would happen. But also, as part of the configuration that we have here in the demo is within Flux and the definition of your customized resources, we've got some depends on logic to kind of help with the order of execution to make sure that, one, we don't want to deploy our app, the demo app, until Linkerd is actually installed. And so instead of having to manually go create pipelines to go through and say, okay, we're going to do one here, this one's done, now kick off the other one, we can define them all. They can all push directly, and then Flux knows to not try to reconcile the apps or the ingress until Linkerd is up, because we need Linkerd as for the core of all our applications. So you can define all that. Does take a little bit longer, obviously, when you're reconciling from scratch. But once everything is up, you get that nice, dependency management order of operations.
Yeah, that dependency management is actually one of the things that's probably the coolest about Flux. It's actually really nice. We're gonna take a look. We will take a look at that in a couple of minutes after this is done, and it's pretty cool, mostly because it's dirt simple and it works really, really nicely. Another question in the chat here: where's Linkerd in the picture as the service mesh? I think we answered that, but Ahmed, if you still have questions about that, then I guess let us know and we can circle back to it. Interesting thing here in this window is that dependency logic that Russ was mentioning in the app. We actually have it set to, I believe we have it set to depend on Nginx and on Linkerd, and Nginx and on Flagger, and then those depend on Linkerd. So in this case, that highlighted line, Flagger became ready, and then Flux went through and went, oh, well, can we do apps? Oh, no, not yet, because Nginx isn't ready. But now Nginx is ready, and the app is ready to go. Interesting thing here, you'll notice that word applied, that is not the word applied and everything is already running as it happens. So we're actually going to watch and let this get into a completely stable state before continuing onward. Is there a way, this is something that I did not have a chance to ask you, Russell, is there a way to make Flux wait until everything is totally running?
So in the customizations, and I think there was one on here, there is actually a wait field. And what you can do is on there, you can set wait true. By default, the wait is false. It just says, here's my reconciliation, here's my customization, apply it. And once it applies, it's done. If you add wait true, it will wait for all the dependencies under that customization to finish. But we did that on some of them, but I don't think when we did on the faces one on the Apple.
Yeah, I think we must have missed that one. So like I said, this is how you know we're doing this live or something like that. So now this is all running, and if I go to localhost, slip.io is kind of a cool service where it will notice this IP address, and we can put anything else that we like in the host name and get back that IP address. So it's a really simple and elegant way to set up various things. In this case, we want faces.slip.io here. We want that URL to resolve to localhost. So if I go there, this is what I see. I've got my grid full of green smiley faces, and they're constantly updating, which is what we want. Also, I have a couple other dashboards. The first one is I've got the Linkerd Viz dashboard, and the second one is the Weave GitOps dashboard. These are not specific to the application, but they give us a bunch of information about whatever application you're running. In this particular case, with the Linkerd Viz dashboard, I'm looking at the faces namespace in particular, and so I get to see things like I have a primary service or primary workload for all of my services, the faces GUI, the face service, the color service, the smiley service, and I get to see that they're all running at 100% success, which is good. And the backend services are taking about 8 requests per second. If we go back to this, there are 16 cells there. Each of them tries to update every 2 seconds. So the math says that we should get exactly 8 requests per second. Since there's a certain amount of randomization going on in there as well, I'll take anything close to 8 per second and call it good. So all this looks like what we would expect to see. You can also see, by the way, that these latencies are ludicrously high. That is because the Faces app is designed to have ludicrously high latencies, not because Linkerd is screwing everything up. If we go look at Weave GitOps for a moment, logging in with my very high security credentials for the demo. This shows us all of the applications that we have defined, all these customizations and home releases and all that. And the really interesting thing for this point is that we get to look over and go, yep, these are all ready. Everything is happy. That's good. So now let's actually go through and take a closer look at what is, how these things are defined under the hood in Flux and Flagger to make all of the things happen that we want to have happen. First thing going on here is we can look back at that overall bootstrap command that I did, and we can notice things like we pointed it specifically at my fork of the GitOps Linkerd repository. We pointed it at the main branch there, and we pointed it at, hey, go look in /clusters/mycluster to get all of the other stuff you're going to use to define what we want you to install. If we look in clusters mycluster, this Flux system directory holds kind of the core components of Flux itself. We're not really going to talk about that. In this demo, we're not really going to talk about that. There are situations where you might want to go through and tweak things in there. Mostly, we're going to concentrate on infrastructure.yaml, which defines the infrastructure for our application, like Linkerd, and apps.yaml, which talks about the application itself. So let's first take a look at infrastructure.yaml. There are multiple YAML documents in here. We're going to look at them kind of one at a time. And we're not going to look at all of them because many of them are kind of repetitive. But the first one is Cert Manager. So we are defining a customization resource. Its name is Cert Manager. It lives in the Flux system resource. And this is basically saying that for Cert Manager, we want to look in the infrastructure/Cert Manager directory to learn more about how to deal with Cert Manager. If we go on and look a little bit further, the next one talks about Linkerd. And for this one, first off, this is that depends on logic that we were talking about. There you go. That's all you have to do to make sure that Linkerd does not show up until Cert Manager is already happily running. That's it. That's pretty cool. For Linkerd, we're going to look in the infrastructure Linkerd directory. There are multiple other things, like I said, in this file. These are the only ones we're going to look at right now because the others are kind of more of the same. Feel free to go and take a look at that in the repo and study it on your own. If we look at the Cert Manager customized files, then there are only a few of them. Cert Manager is fairly simple. This first customization file, and again, sorry, this is a pattern that all of the other ones follow when you're creating these customization resources. Start by looking at customization.yaml and then work your way through it. So this one basically says for Cert Manager, we're going to pull in the namespace, repository, and release YAMLs. That's it. Most of these, actually all of these in Cert Manager's case, are just going to be defining resources in the cluster. That's all they need to do. So the Cert Manager namespace YAML literally just defines the namespace for Cert Manager. Very profound. Repository is telling Flux where to go to find the Helm chart that we're going to use to install Cert Manager. The last thing in here, release.yaml, it literally tells it which chart to install, which repository to get that chart from, and we get to set the values when we're doing a Helm installation. So one of the really important things to remember here is that Kustomize can do patching, but you don't need to use it for patching. You can also just use it as a way to sequence some installation things. And in this case, that's all we need to do for Cert Manager is just go ahead and set up a few resources and then trust Flux to go through and do the Helm install for us. There is one other thing in the infrastructure directory that is important to look at. Buried in the infrastructure flagger files, there's a particular thing that is worth a little bit of attention. And that is, and Russ is going to keep me honest because I might not explain this one correctly, but Flagger needs to be able to watch resources in the cluster. And you need to be able to tell it things like, hey, watch the resources that match this set of selectors. By default, for some reason I don't fully understand, Flagger does not know how to use service selectors. It knows how to use other things, but not services. For this demo, we actually found it easy to go ahead and use service label selectors. And so we needed to actually add that down here to the selector labels when we're installing Flagger. Anything that I botched on that one, Russ?
I just want to just point out, it's not that it's actually looking for, if you have in your deployment and your services, if you have the selector, the default ones are app name, app.kubernetes.io. In this particular demo, we actually had a selector that said service equals, faces. And so we just need to tell Flagger that, hey, this is a selector that we want to use. So if you have any custom ones you want to use outside of name, app, or app.kubernetes.io/name, you need to specify them in here. If you're using those other ones, you do not have to use you don't have to specify line 23 at all. But for this demo, we are using a special one, so we added it in here.
And the reason we ended up using the special one is just because the way the Faces app install files are written, it was convenient. There's no particular magic to it. We could have gone through and changed the way the Faces demo worked too, but we didn't feel like it. So we did it this way instead. Also worth pointing out, I haven't really talked about it, but there's obviously a bunch of other stuff in these files, like the interval that it'll go through, the interval for Flux and Flagger to go through and check to see if things have changed and all this kind of stuff. We'll touch on that a little bit later. But the Flux and Flagger docs are going to do a better job of explaining all of those little details than I will, for sure. Would it be easier to have label called Flagger watchable true or something? You could. A lot of that is going to depend on really whether you're trying to bring in things that are already defined differently or whether you're doing this on a completely green field. We chose to use an application that was already written, so we just adapted Flagger rather than adapting the application. Both will work, though. All right. So that was a quick look at the infrastructure part, where we're talking about things like Cert Manager, Linkerd, Flagger, or Cert Manager, Linkerd, the Nginx, Ingress, all that kind of stuff that the application is going to live on top of. Before I go diving into apps, there is another question about whether the selector label works across namespaces and tenants, and I am going to punt that one to Russ.
So this is the selector is not I would say not in Flagger. It's in your service definition. So when you have your services and your deployments, and you have your app selector in there, those are the selectors that it's looking for. So typical Kubernetes config app selectors in there, and you can have app, you can have customized, you can have any X number of labels that you have on there, but those live within a namespace usually, because you're going to have what your service is going to reference a deployment that's going to be in that same namespace. Those are the selectors that we're talking about in there, and those labels that are associated there.
And we're actually going to talk about namespaces in just a moment, I believe. So yeah, if we look at apps.yaml, clusters my cluster app.yaml, this is the top level thing that's talking about defining the application. This is very similar here. It depends on Flagger and Ingress Nginx, back to the depends on logic. And we need to look in the apps directory to get its magic files. If we look in the apps directory, there are more files in here than there were for the other ones, but that's okay. Again, most of them are straightforward. The customization file, like I said, we're going to start there. Really important note about namespaces in here. So we've defined that this customization is going to live in the Faces namespace, but that also defines the namespace for all of the other files that we're pulling in. Even if one of those files tries to mention a different namespace, the one in the customization will win. Usually that's a reasonable thing. Occasionally might be something you have to pay attention to. So another note about namespaces, actually, some of this is just convention, right? But by convention, infrastructure-y things you can put into the Flux system namespace, and application-y things you want to put into something different. So this is our application. This is not part of the infrastructure. So we're going to put this in its own namespace called faces. The namespace, namespace creation again is straightforward. There's one thing to call attention to here, which is that we are telling Linkerd to just go ahead and any pod that's created in this namespace will automatically get pulled into the Linkerd mesh. We could also do this by adding this annotation to the pods directly, like modifying their deployment pod templates to have the annotation, that sort of thing. We're doing it this way just because it's simple, so why not? Next up, faces sync is one of the more complex ones here. Faces sync, so the first thing that's relevant here is that faces, the code for the faces demo and the YAML files defining how to install the faces demo do not live in this GitOps Linkerd repo. They live in a different repo. In this case, I'm telling it to look at my fork of the faces demo repo. The main faces demo repo is github.com/buoyantio/faces demo. I forked it so I can go and be committing to it for this demo. We're going to look at the main branch of that, and we are going to ignore just about everything in that repo. We're just going to pull this subset of YAML files from this one directory in the repo, because that's all we need to tell Flux how to install the faces demo. If we go take a look at that quickly in our browser, this is the fork of the faces demo. And we can look in the Kate's directory in 01 base, and we find, a bunch of YAML. So for example, faces GUI.yaml is a simple one. It defines a service and a deployment for the faces GUI. That's it. Faces.yaml is more profound because it has all the backend services in it, but it still just defines some services, defines some deployments. Finally, we have these profile files that we're bringing along. These are Linkerd service profiles, and we will touch on this a little bit later in the demo. There are other service mesh academies that cover these in great detail, but basically this particular service profile is really just saying, hey, Linkerd, you should expect that when people talk to the Smiley service, smiley.faces.service.cluster.local, you should expect them to be doing get resources and, just to the root path. And all of those for statistics gathering will get bundled into this one stats bucket. Like I said, we're going to go and mess with these a little bit more later in the demo. Okay. I see another question in the chat about disabling pod injection of the sidecar. Yes, you can. If the injector is enabled in the namespace and you want it to not inject a particular pod, you can put the linkerd.io/inject:"disabled" annotation on it and prevent injection from happening for that pod. I am not going to lie. I don't think I've ever seen a case where that was something that I wanted to do, but I'm sure it's out there somewhere. Back to the faces thing. The second document in faces sync uses that patching ability of customize to go through and change the YAML files that we're bringing back in. So in particular, the YAML files that we're getting out of the faces demo repo set an environment variable called error fraction. And the error fraction in the normal faces demo install is basically set to make these things fail fairly often. Because again, the point of the faces demo is to fail and take a long time and let you look at resilience with it. We don't really want that right now. So we are explicitly going to use these patches to set the error fraction to 0 so that they don't fail all the time. I'm only looking at one of these. This is the one for this is the one. You know what? I misspoke there. This is affecting the face, smiley, and color deployments. The second block affects the faces GUI deployment. They're different because these three start off including an error fraction, The faces GUI doesn't actually have an error fraction set by default, so we're going to explicitly add one and make it 0. All right. So, yeah, that's just to reiterate. We really don't want things failing right now because we just want it to be smooth and to show off all the green smiley faces. The next thing we're getting into here is faces ingress. This is long but straightforward. This is the ingress resource that our Nginx instance will be looking at. This is honestly the only one we really use in the demo. If we see a path of /, we go and talk to the GUI. If you want to test things, you could curl to /color, but we don't actually need that. And there's a similar one for /face and /smiley. Finally, we define a canary. Actually, we define multiple canaries, and we define an A/B test. For the backend services, we are telling Flagger, when you see a change to one of the backend workloads, don't just send all the traffic immediately to the new thing. Instead, set it up as a canary and start routing a little bit of traffic to the new deployment so we can make sure it's going to work. Specifically, and we're going to look at the one, this is where we're only looking at one of them. We're only going to look at one of these because we define a canary for the face service and for the smiley service and for the color service, but we're only going to look at face because they're all the same. So we start at 0% going to the new deployment. Every 10 seconds, we will add 5% to the fraction of traffic that we're sending there. Once we hit 50% with everything working well, we'll call it good and then cut the other 50% over all in one fell swoop. While we're doing this, we're going to sample the request success rate, and we require it to stay above 70%. If we see it under 70% 3 times across the entire rollout, we will give up and roll it back. Finally, let's look up here. I should have pointed this out in the beginning. This is specifically going to be applied to the face deployment. And the other thing is that rather than rely on the user to provide load, we will actually use Flagger's load tester to go and supply load so that we can make sure that we're getting traffic to measure things with. Now, that applies to the backend services. For the GUI itself, it makes more sense to do A/B testing, where rather than just a user shows up and they randomly get one of your things, it tends to be a little bit more polite to the users to key them on something coming in about that user so that they have a consistent user experience. In this case, we're going to use the, that's a typo. We're going to use the xfaces user header. And whenever we see that with the value test user, they will get the incoming deployment and everybody else will get the older deployment. Once again, we're going to demand a 70% success rate. So the target here is that we need to look at the faces GUI. Making this kind of thing work requires Flagger to interact with the ingress. So we need to tell it which ingress resource to mess with. There's no weight manipulation here. If you come in as a test user, 100% of your traffic goes to the incoming deployment. But there's still a time period baked into this where we're going to do 10 intervals of 10 seconds apiece. And again, if we see 3 of them drop below 70%, we give up and roll back. This is the most important bit, really. This is the one saying traffic that matches xfaces user, test user, that's the one that goes to the new deployment. We've got our usual metrics thing requiring 70%. Now we have 2 webhooks. So one of them can supply traffic for the test user and the other one can supply traffic for a normal user, and we can watch both. Russ, once again, anything else you'd like to call attention to as we walk through this? Some of this is a little complex, but it's all there in the files to read over and study.
Just one. Can you open back that A/B test again? Sorry.
You're making my life hard, man.
Sorry. I just wanted to point out that if you notice between the canary deployment and the A/B, oh yeah, that'll work. The kind is actually still canary. So no matter what your definition is, it's still going to be canary. The difference in if it's a canary versus an A/B test versus blue-green test, however you're going to kind of configure all the stuff, comes in the actual definitions themselves, and it comes down to particularly the analysis phase that you have in here. So if you have like a step weight and a max weight definition on here, Flagger's going to know that's going to be a canary. Like a true canary deployment. If you go into like the A/B test, we don't have that. We have those header refs, along with the ingress ref. Then it knows that it's going to be doing an A/B test. So in the Flagger documentation, there's all different stuff, and you can do different things. You can match on headers. You can match on user agents. You can match on whatever. You can kind of piece together whatever fits your need in your environment. The other reference that we don't have in here that is kind of good to call out is you can have autoscalers as well. And if you have autoscalers defined for your deployments, you would want to add that autoscaling ref in here as well. And that helps even with some of the resource utilization and deployment config as things are rolling up as well. They're not required. For this demo, we didn't have autoscalers, so we just didn't add them in here. But if you have one, it's a good idea, and definitely you want to add it into this definition as well.
Yeah, for this demo, we're kind of deliberately doing a bunch of stuff in ways you would not want to do them in production. So in particular, we only have one replica of everything. We don't have any autoscalers. Don't do this in production. It's a bad idea.
Great for demos, though.
Great for demos, yeah, because I mean, I don't really want to be running 47 different things in my K3D cluster. Chris also points out, make sure you scrape your metrics at intervals that Flagger can check against. Yeah, that makes a lot of sense. If you're scraping your metrics every 5 minutes and then asking Flagger to check them every 10 seconds, this is not going to work out very well for you. And that would be I'm not actually sure what that would look like. That would probably be very, very confusing, actually. Okay. Yeah, thanks, Russ. That was a good point about both of these being kind canary. That's something that confused me partway through this one earlier. One other reminder that I was going to point out, actually, I guess 2 reminders on this slide. One of them is that remember that the Faces customization resource lives in the Faces namespace, and we're going to see that a little bit later in this demo. The other one is, this looks like an awful lot of stuff going on under the hood. The nice thing is that a lot of it is stuff where you get to set it up once, and then your app developers can just go on, do their job, and not really have to think about it, which is a thing that we kind of like when we're working with stuff like this. All right, so we are actually going to demo a rollout at this point, and we are going to start by demoing a failing rollout, because those are kind of more dramatic than successful rollouts some of the time. So what we're going to do here is we're going to edit Faces sync, and we're going to deliberately set the error fraction for all of our backend services to be high enough to fail. So if I come over here, I can come down here. We'll set that to 75%. And actually, I see a note on Slack about re-summarizing what we've gone through. Kind of. So we talked about Flux's bootstrap process, where Flux will start by installing itself, then reading all your definitions of other things to install, and then it'll go and pull all that stuff up in the beginning. We actually watched that happen. We talked about how you can go through and watch the customization resources with the Flux command to see it happening. We talked briefly about how we needed to change the Flagger installation to allow us to use the service label for the demo. Then we walked through really an awful lot of stuff about how we actually defined the application getting pulled in, the way we defined both the patches that we're going to do, where we're going to initially get the YAML for the Faces demo from, and then we talked about how we're defining canaries for the backend services and an A/B test for the GUI. Yeah, I think that covers it. And we talked a little bit about some of the gotchas as you go through these things. Now we've just modified facesync.yaml, but that has only been modified on my laptop. It's not in Git yet, so Flux isn't doing anything with it. Double checking to make sure that we actually got the right change. That is the right change. We're changing from an error fraction of 0 to an error fraction of 75 for the face, smiley, and color deployments. And we are now going to go ahead and commit that change and push it up to my repo. So at this point, the change has happened in Git. It's stored in the repo on GitHub. And we could just sit here and wait for Flux to go through and pick up that change. But we have told Flux that we only want it to look for changes every 10 minutes. And I am not willing to wait that long in this demo. So instead, we're going to trigger a manual reconciliation using the Flux CLI. Again, you do not have to do this in production. You probably don't even want to do it in production. It's probably much better in prod to just let your developers know, push the things up, and then in a few minutes, it will magically happen. But in our case, we're going to do it by hand. And at that point, there's a bunch of stuff that will happen. Flagger will start updating Canary resources in all of our namespaces and make everything happen. Flagger will also tell Linkerd to start routing traffic according to what the Canary weights say. And the Faces GUI will hopefully see responses coming in from our new deployments. Since our new deployments will be failing 75% of the time, we should see some failures in the GUI. So let's go ahead and do that. We're going to trigger this rollout. I probably should have changed that to say we may see an error message about Flagger not being ready. Oh, good. We didn't see it this time. And now we can start watching the progress of the canaries. So we can see the weight changing as we go through this. We can hit mute to cough, and we can come through and take a look at what's going on in here. So we've started to see some failures coming in here. Did you see those? There were some gray backgrounds that showed up. That's a failure of the color service. This red frowny face is a failure of the face service. I haven't seen any of the smiley service yet, but whatever. I'm sure they'll be there. There you go, the cursing face. That's a smiley service failure. And if we come over to Linkerd, the Linkerd Viz dashboard, we can see these non-primary deployments exist now. They're in the mesh. And we can also see that they're showing us really pretty grim success rates, except for Smiley. I don't know what's up with Smiley. Well, like I said, we're demoing. There we go. Smiley just took a second to catch up. This is how we're doing it live, right? And if we come back here, we still see some failures. But if we go all the way back here, we can actually see that Flagger has given up on everything except the Smiley service because it just got too many failures. If we come back over and look at Linkerd, we now see that the color and face incoming deployments have dropped down to 0 replicas. Smiley is still hanging in there, but I don't think it's going to last too much longer. Yep, Smiley just failed, and now we see that Smiley has dropped off to 0 as well. Since this was a failed deployment that Flagger just rolled back, if we flip to the GUI at this point, we just see green smiley faces again because now nothing is wrong. One kind of interesting point about this is that at this exact moment, the cluster and the Git repo they have diverged a little bit because the Git repo says an error fraction of 75%, but what's actually running in the cluster is an error fraction of 0 because that got rolled back. So as with many things in the world of cloud native stuff, there's the operational side of operating the cluster, but there is also a process aspect to this where you really need for something to be keeping an eye on whether you have failed deployments so that you can go fix that, even though Flagger has masked this problem for us. Is there, Russ, do y'all see anything in the field for particularly good ways to deal with that kind of stuff or particularly bad ways to deal with that kind of stuff?
It kind of comes down to enterprise, what your enterprise regulations are and everything else like that. Some areas, typically a lot of the we'll see, Slack notifications that go, to let users know that it failed. You can set up email notifications. If you've got like custom providers, you can hit custom webhooks to trigger off. If you need to create, I don't know, tickets in ServiceNow or anything like that. It kind of comes down to, whatever your regulations are. You can just configure those notifications in, there's a number of different ways of doing it. The way I would say not to do it, don't ignore it. That's probably the biggest no-no. Other than that, as long as you get notifications somewhere that works, that's whatever fits your needs.
And although we're not going to demo it today, is it Flux? It must be Flagger. Flagger is the one that can be configured to raise alerts and do all the fancy stuff when things go wrong, right?
Technically both. In this particular case for theirs, it would be Flagger that would do for the Flagger rollout notifications. You can also configure Flux with notifications that even if the customized reconciliation fails from the core, you can get notification on that, because if that fails, then Flagger doesn't even try.
Yeah, that makes sense.
So you can do it at both levels.
Right. And there's a question in the Slack about some of the Flux notification integrations. You have a quick summary of what sorts of notifications it can deal with? Like,
can Flagger raise some kind of alert when a rollback is triggered? Yes, so that's what we're talking about. It's like in the Flagger, in the canary definition, you can set those alerts to on rollback. I believe you can even set it on success if you wanted to as well, but most of the time, most people just care about the failures. That is in the canary definition itself. So yes.
And then something about MS Teams and PagerDuty and I gotta imagine you can do PagerDuty for sure.
I think it's like there's always, with most of these, there's a break glass webhook, and so if any of them support like any sort of like webhook solution, you can use that. I would have to double check. I don't know if we have native MS Teams PagerDuty, or I can't remember off the top of my head. I know Slack is one. But I would double check. But as long as it supports any sort of webhook or anything like that, it should work.
We can look that up and try to post an answer someplace. All right. So while doing that, I'm going on here with the next step, where we would like to show a successful rollout, because come on. So I'm just going to force the error fraction back down to 20, which should let the rollout succeed, because that'll be an 80% success rate greater than 70%, but should still show us some, kind of different stuff, because it's no longer going to be 0. Exactly the same thing going on here. Let's double check to make sure I got it right. In the real world, you'd probably be doing this as a pull request with review and all that. We want to commit that. We're going to go through and push that change out. And this time we're going to trigger the reconciliation from the GitOps UI. I can come over here. I can say pick apps and sync. A bunch of things have now become not ready because they're in the middle of being checked to see about synchronization. It looks like we basically are looking at apps and its dependencies. All the other ones have now become ready. Apps is not ready. Apps is now reconciling, and off we go. Flip back over here for a moment. And, again, we'll still watch the progress over here with the CLI. And we can come over and take a look at Linkerd, where once again, we see our incoming deployments have shown up. They are meshed. They should be taking a little bit of traffic. So shortly, I think we'll see the success rates change. In the meantime, we are seeing a couple of errors over here. So that's a good sign for things really are changing. There we go. Come on, you can do it, face service. Okay, so now all of these are over 70%, closing in on 80. So I think we're going to be able to have this work correctly. And I was just talking about that without showing it to you. That was brilliant. These should land at right about 80%. And we should see a few failures going forward. We come over here, we've gotten up to 30%, 35% with some of these. So Still not at the point where we're ready to cut over yet. Still hovering around 80%. It's always a little bit weird to be going through and, now we're going to do a rollout of something that doesn't quite work, but is still good enough to roll out and succeed. Still hovering around 80%, which is good. You can also, we didn't really talk about this last time, but you get to see the requests per second numbers change as traffic flows between the two. And since we're deliberately running traffic generators, then you'll see these things spike above actual use while the deployment is happening. If we come over here, we can see that these are all getting promoted. They've all succeeded, which is great. That was a little bit fascinating, seeing everything turn red for just a moment over here. There was a brief second in there where everything went red while it was getting promoted because we're not doing any auto scaling or polite deployments or anything like that. And now we're back to the case where our non-primary services have gone away. The primary services are handling all the traffic again. Now, since we passed the minimum success threshold, the rollout succeeded. It went forward. We got changes. We can see those changes in that we now have some errors, but that's kind of what we were looking for. And the next thing we're going to do here is demonstrate that the things that we've done so far, we've just been changing the faces sync file. But remember, faces is getting pulled from another repo. And Flux can cope with it if we change that repo as well. So what we're going to do here is we're going to go through and actually make a change in the upstream face demo repo. I have a clone of that repo kind of as a sibling, so I just get to edit it directly. And what I'm going to do here is I'm going to change the smiley deployment. And I shall set a new variable, being extra careful to not have Max put tabs in this file. I'm going to change the kind of smiley that gets returned when everything goes well. Instead of the normal smiley, I shall now have it return a hard eyes smiley. Why not? If anybody is not familiar with this particular idiom, this is the way you tell Git to use a different repo than your current directory, a different workspace than your current directory, I should say. So yes, that is the only change that I wanted to make. That's good. So I'm going to go ahead and commit that. And then I'm going to push that up. Now, once again, to make this happen, we're going to need to trigger the rollout instead of waiting for it. And in this particular case, we want to tell it to look at the faces customization in the faces namespace rather than the apps customization. And if I remember that correctly, that's because if we just change the apps customization, then it's going to look for changes to the definition of that external repo rather than changes in the contents of the external repo. Now, how we actually watch things proceed at this point is exactly the same as before. We can come over and look at this. Hey, I already saw hard eyes. That's nice. One thing that's interesting is if we flip back over here, we only see the smiley canary start to progress because that's the only one we changed. Another thing that I'd like to call your attention to in passing is a lot of the time you'll see canaries being done where the ingress is managing the traffic splits. The smiley service is below the ingress. It's down in the call stack where the ingress can't see it at all. So being able to do a canary for something that's deep in the call graph like that is a particular strength of the service mesh. If we come over here, we see some more hard eyes. Interesting thing, at least an interesting thing to me, is that even though the smiley one is the only one that's progressing, we still see the color and face services spin up a new deployment. They're not taking any traffic, so we don't really have to care. But that's something that you might notice that's that's okay. If we come back over here, we're already up to 40%, so this will not take too much longer, which is good. And I don't know, Russ, was there anything else you wanted to point out about the distinction between customizations there? While we all
No, it's just
watch hard eye
worth kind
smiles.
of pointing out that like you touched base that the customization in the apps directory is pointing to how you want to configure it in the other in that faces directory that we defined. But then changes there if you have it pointing to another repo, you just want to make sure that you're reconciling the correct customization. Because in this particular case, we got a little bit of, we'll call it customization inception, if you will, where you've got a customization that's actually creating another source and another customization. And you just kind of keep track of where your changes are. And so you make sure you make the changes and the patches at the right layer. If we had put that particular patch in the faces directory customization right in there, it would not know about those deployments and it would not have made those patches successfully. It would have potentially add that patch to another deployment or just ignored the patch altogether because they didn't find anything to match up against.
Yep. And we could, for the record, we could have not bothered triggering the reconciliation. We could have just let Flux do it on its own. But again, we didn't want to wait. And we could also have done this particular thing with a patch in the upper level customization, but it's much more awkward to do it that way. It's also much less like what's going to happen when your actual app developers make a change to the application. Okay. So last thing we're going to look at here, I'm going to show this, and then I think we're going to circle back and try to pick up questions. But the last thing here is we want to show that A/B deployment that we were talking about. So again, with the A/B test routing, we want to see xfaces user needs to be test user to trigger this A/B deployment, or to cause traffic to flow to the incoming deployment for the A/B thing. Now, the way we're going to do that is this browser. If you look up here, you can see that it says user unknown because this is not actually setting xfaces user at all. But I also have this browser over here, and hopefully if I reload, it'll work. Oh, good, it's working. This one, I'm using the mod header extension to force xfaces user to test user. So we get to see both a normal user and a test user by running two completely different browsers. So if we come over here, now we're going to go back to faces sync just because this is an easy way to do it. But we're going to modify this to set another environment variable on this one. This is the faces GUI deployment that we're looking at. And we are going to add, again, being careful to not have Emacs put tabs in here. By the way, I should point out that the demo will actually, if you run this at home, the demo will actually invoke $editor. So you're not tied to Emacs if you're a VI person. So we will set color to have a value of light cyan. Save that. And note, we did this unconditionally, right? We just, that variable, that environment variable changes the background color of the GUI, and we did it completely unconditionally. We're going to rely totally on Flagger to only bring the test users to the light cyan background while we're in the middle of our deployment. So that is the change I wanted to make. Well and good. Add that. Push that change up. And now we're back to reconciling the apps customization rather than the lower level faces one. So at this point, you remember when Russ was saying that we did this is still creating a resource of type canary. So in fact, when we go to watch what's going on, we're going to watch the canary resources again. And we should see that the faces GUI shows up as doing something. Come on, anytime. There we go. It's progressing. So at this point, if we flip over to our normal user and reload, we have white. Very good. If we flip over to our test user and reload, we get nothing. Oh, we get mod header getting confused. That's what we get. There we go. Now the test user is set correctly. And in fact, we get a light cyan background there. If we come back to our non-test user and reload again, we still have white. Excellent. If we look at this in Linkerd, we can see again, we've got all of these things in the mesh. In particular, we get faces GUI primary, but we also see, remember how we were generating load tests for both of these? So both of these are taking a fair amount of traffic. It's not just coming from the user. If we flip back over here, you know, I'm not going to lie. A feature request here would be for it to give me some indication of how far along we were, rather than just constantly saying a weight of 0. But, you know, we'll progress along, and at some point soon we will see that it's promoting rather than progressing. And one more time, we can reload there and it still works. We can reload here and we still get light cyan, which is all good. And so now we just chill out for another minute and wait for this to promote. After we do that, we get to try it with the non-test user and hopefully see light cyan there as well. All right, promoting. We'll preserve the drama by starting with the test user, and we reload here and we get light cyan. And then we come over here and we hit reload, and it's doing the same thing there. Come on. So the moral of this story, by the way, is don't do your deployments for demo things. Do them in a way that doesn't cause problems like this. There we go. But you can see now this is light cyan, now that everything has gotten sorted out with doing deployments that only have one replica and beating on them and things like that. So I believe that that's it for the demo. I'm going to talk really briefly about some of the things that tripped me up while I was trying to get all this stuff set up for this demo. The first thing that I ran across a couple of times was things where when something didn't work, it was interesting to figure out where to go. And it turned out that one of the most useful ones was actually just looking at the Kubernetes events, because Flux and Flagger post kube events as things are happening, and they will often shed some important information in there. The big one for me was there was a point early on where I had misconfigured the faces sync to look at the wrong Git repo. So I was telling it to look for a branch that did not exist in the repo that it was looking at. And that was deeply, deeply confusing until I looked at the event log and found that it had posted a very helpful thing to the tune of, dude, this doesn't exist. I can't fetch it. And then things were much easier there. Other places you can look. kubectl describe pods will show you interesting things about the pod, notably including events that pertain only to that pod. So that can be a really handy way to sort of narrow your focus onto a particular thing rather than looking at the whole application all at once. And finally, the Flux and Flagger controllers log a bunch of stuff. In many cases, they will be logging more stuff than you really want to look at, but this is another helpful thing that you can look at as you go through. In particular, there's a Flagger deployment in the Flagger system namespace that can talk to you a lot about some of the things that Flagger is doing. And in the Flux system namespace are controllers. You kind of need to pick the one that corresponds to the way you're doing things. So in our case, we're using customizations a lot. So the customized controller is the one that you would want to look at if you need to go that far. Russ, did you want to add anything else on this stuff?
No, not on this. I was gonna to show the next stuff, but I think actually even will address one of the questions that we got in here as well.
Yeah, I think so. This is the Q&A part, well, for at least a little bit. I see a question here about whether Flux will apply failed deployments again. Yeah, what does it do there?
So the answer is no, because basically what's going to look at on here is that from a Flux perspective, let me take it back. Depending on what you're looking at on here, Flux has made the change and Flux made the reconciliation. Flagger did the rollout. It failed. It rolled back. Flux doesn't know about that part. Flux is looking at the customization and the deployment that it's sourced. And when it goes to reconcile, it's going to see that SHA is still the same. So there's been no change on there as well. So in order to fix a failed Flagger deployment for whatever it is, you need to actually make the change and recommit it, update the SHA on there as well to kind of help force the traffic on there. Now, what you might, when you get to those like hard sync intervals, it may do and apply again, but it's not going to really have any impact until you actually change the source and that was what will actually truly trigger a new change and resolve like the failed deployment.
That
So
ties into a question from the Slack, from the Linkerd Slack. Is there a reason in principle that you wouldn't want Flagger to go and send back a PR to basically update Git to match the reality of the cluster? My answer to that is twofold. One of them is it makes your permissions really complex, and circular. There's some circular stuff happening that's weird. But the other one is, in my mind, and it's going to be interesting to see what Russ's take is on this one, but in my mind, I don't think you ever want the cluster to win over Git. I think the purpose is that Git is supposed to be the one source of truth. And so you never, ever want the cluster to be telling Git that it's wrong. But like I said, I'm going to be really interested in Russ's take on that.
I mean, that's the correct take on there. Is particularly Git is your source of truth. That's what it's supposed to be on there, and that's where everything's supposed to be on there. And if it doesn't reconcile, and that's where having those notifications and the information to make sure everything kind of rolls back on there as well, because it's kind of the same fold. If your customization is wrong, not even if you're using Flagger, if your customization is wrong and Flux can't reconcile it, it's not going to be able to push back on there. You're going to want the notifications to know, because like you said, the permissions aspect on there is that now you're talking about, instead of having read tokens to just kind of pull the code in, you have to provide write tokens, which can cause a security risk. And then you have to actually be able to push back. And how do you make sure they don't push back to a branch versus main, or however the code may be? There's just a whole extra layer of complexity and security concerns that come with that as well, that having just the proper notification chain to let you know that, hey, your deployment failed, and take the appropriate action that you need.
And the Slack commenter continues on by pointing out that you really are relying on people to keep an eye on the notifications and make sure that things are correct. Yeah, you are. There's, like I said earlier, there's the technical operations aspect of keeping your cluster running, but that has to tie back into the practices of your business or the practices of your organization to be doing the right thing from the organizational point of view. That is not a technical question. That's entirely an organizational question. That's sadly not something that we can dictate down from the technical trenches. One more question here. Is there a web UI for Flux where you'd be able to see and show things about new versions and things like that? And for that, we shall hand it over to Russ to give us a quick look at the enterprise version of GitOps.
Good question to ask the transition here. So I kind of wanted to show. So it's part of the app. There are, as far as Weave GitOps, there's actually two versions of it. There's Weave GitOps open source, which we've included as part of the demo here, and you can go and you can take a look, and it shows you the customizations, your Helm releases. You can come in here and you can view a customization, for example, here, and you can tell exactly all the details and everything that's kind of related underneath that particular app. So here's, with that app, my app's definition, here's all my faces. They create canary deployments, they create ingresses, they create namespaces. You can view all of that on here. And it's basically just the current state of the Flux managed resource. So this is essentially just a UI for Flux, which kind of gives to the next stage, which is the Enterprise Edition, which goes with a lot more features as well. Particular for what we're talking about here, we call it delivery. This is essentially your Flagger dashboard. So in here, instead of having to go through and watch your Canary deployments through the CLI and to go through everything, you can actually view everything right here. And you can see that through color, face, faces, GUI, smiley. There was a little icon to say these are Canary releases. This is a blue-green release. And you can actually monitor the whole process of everything right here. And just kind of show that off. I'm going to kind of switch back. And I've got another demo that currently, let me go here real quick. Of the hard eyes demo. This is everything being happy that we had. I'm going to make just a quick change here just to make our hard eyes come back. Ooh.
Unless anyone get confused about how all of this got out of sync, this is a different repo, a different fork of the repo, and a different cluster than the one that I was using. So
correct. And I'm using K3D. I'm using a kind cluster. Demo works on just about anything. As long as you got an empty cluster, everything should start. Let's go back in here real quick. I'm going to just reconcile apps. I'm just going to sync it here to the UI just to show kind of like what we did before. We should see the same stuff. And perfect. There we go. Now we're reconciling. Let's let this thing say ready. Perfect. And we're going to come over here. Oop, wrong tab. There we go. And there we go. And now you can see actually Smiley's running, and you can actually see the status of the rollout right here. And to kind of answer, Flynn's question before about, the CLI enhancement, we have the enhancement in the UI that actually shows the iteration count and everything that goes on through here. Yeah, maybe getting in the CLI is a good idea as well. But you can kind of see in here, if we actually go dig deeper into it, you can actually get the phases. You can see how everything's progressing. And if we come over here, there's our green, and you can see the hard eyes are getting kind of sprinkled in here as well. Now, to answer about the history on here, we don't have too much stuff that actually shows like the evolution, I would say, of your app release on here. Especially with everything we're doing for this demo, we're actually using the same version. We're just changing environment variables. So if you look at the deployment, the promoted version is still going to be, at the end, it's still going to be 061. But we're just changing environment variables to show the employment piece on here. We have some pieces in the work that I don't have on here as far as pipelines go that can actually show your kind of the evolution of your app from like dev staging to prod. If that's something, through this UI as well, you can see that dev is on version 0.8 and staging is 0.7 and then prod's at 0.6. And you can see exactly where everything's at in your chain and even have the ability to promote, or create the pull request to promote from dev to staging to prod. I don't want to have that in here, but that might be part of what your question is. So I just wanted to call that out, that these UI features that is something that could be of interest. Once everything goes through, this shows everything's great. It should be promoting.
And we should see
over here. I just wanted to show all the angry faces. This is what we were talking about before. These are single deployments with no readiness probes, liveliness probes, anything like that. So when it makes the cutover, that's what you see. Again, demo purposes for prod.
Yeah, don't do
use
that.
Multiple deployments. But now everything's happy. So
nice.
Just kind of want to take a little bit to show that. Everything was happy. I think my cluster. Sometimes with these things kind of I ran out of memory from time to time as well. They're running on local box.
Yeah, it's
don't
not
run
just
prod
kind.
off the local cluster. Moral of that story. So, but now everything it looks like it fixed itself. So
nice. All right. So thank you, Russ. Let's bring this one back for a second. Quick reminder, that's this is the source repo for the demo that we just did. That talks about where to go to set up other things and what forks you need and all that. Feedback is great. there's a slide that's coming up at the end that will have email addresses and such. Or again, you can always find us at, you can find me at least at the Linkerd Slack and the CNCF Slack. You can find Russ on the CNCF Slack. Love to hear from everybody. And so we have a couple more things here. This is Weave GitOps, the enterprise bit that Russ was just talking about. Buoyant also has a commercial offering called Buoyant Cloud. That's the URL for that, buoyant.io/demo. It does a bunch of the same things that the Viz dashboard does, but it can do it across multiple namespaces and do some other cool stuff. And last but not least, we do Service Mesh Academy every month. The next one coming up is going to be talking about what's coming in Linkerd 2.13. That will be on the 16th of March. Right here, buoyant.io/SMA. So, contact information one more time. We have a few more minutes for questions if anybody has anything else on their mind. And yeah, Dominic, you're right. Saying it works automatically does jinx everything. This comment from the Slack channel. So we'll give, a minute or so if anybody wants to toss stuff up. And if not, thanks very much for joining, and we will see y'all next time. The link to the CNCF Slack. I should have known somebody was going to ask that. Here we go. It is... I believe that this is the link for the CNCF Slack. If anybody goes to that and it doesn't work for them, I don't know, email me or something and we'll get it sorted out. I'm going to put the CNCF Slack in the workshop channel in the Linkerd Slack as well. There we go. All right. I think that'll do it then. So thanks everybody for joining. Much appreciated. Always nice when people show up and watch and interact. Thank you, Russ, for showing up and handling all of this Weaveworks stuff, especially for answering lots and lots and lots and lots of questions while we were prepping this. And thanks to Steve behind the scenes for keeping an eye on other stuff going on.
Thank you for bringing me in.
Absolutely. We'll do it again sometime.
Definitely.
All right. Sounds good. Talk to you all next month.